right. So good morning, afternoon, evening, wherever you are. Welcome to our Center for Pedestrian and Bicyclist Safety webinar. My name is Nick Ferenchak. I'm the director of the Center for Pedestrian and Bicyclist Safety and also a professor in the Civil Engineering Department at the University of New Mexico. So the Center for Pedestrian and Bicyclist Safety is a 5-year center supported by US DOT. In addition to being led out of University of New Mexico, we've got San Diego State, University of California, Berkeley, University of Tennessee, Knoxville, University of Wisconsin, Milwaukee on the team. And we've got lots of research going on, so definitely feel free to check out our website, pedbikesafety.org, to look at our research. But we've also got a number of different ways to get the research out into the real world. So we've got our webinar series, as you all probably know. We've got several more webinars scheduled for 2025, so you can go to our website and check those out. We've also got a newsletter. If you go to our website and go to the bottom, you can sign up for the newsletter. And then we also regularly update our LinkedIn with all of our papers and publications and reports and all that, so you can follow us there. So we have two great speakers today. Update on the NACTO and AASHTO bike design guidance. If you have any questions as our speakers are presenting, there should be a Q&A box on the bottom ribbon of your Zoom screen. You can type in your question there, and our program manager, Ben Garland, will be moderating the Q&A at the end of the session. And without further ado, let's jump into it. So our first presenter is Cary Bearn. So Cary serves as NACTO's Senior Manager of Multimodal Design and Programs, where she oversees the creation of design guidance for safe, equitable, and sustainable urban streets. She led the development of the Urban Bikeway Design Guide, 3rd edition, which provides updated technical and planning guidance for connected, equitable bike networks. She also authored 7 working papers on topics like innovative bikeway materials and network connectivity, supporting planners and engineers in building bike-friendly cities. So Cary, the floor is yours.
Great, thank you. And thank you for having me. I'm excited to share a little bit about what's in this new NACTO Urban Bikeway Design Guide. Okay. All right. All right, let's get started. So I will be sharing a little bit about NACTO as an organization, and then spending the bulk of my time getting into what's new in the bike guide and some of the highlights from each of the chapters you see here. So NACTO stands for National Association of City Transportation Officials. NACTO is a membership organization of almost 100 transportation departments and transit agencies across the US and Canada. We work with our members and with staff at cities to make their transportation networks safe, sustainable, equitable, and accessible. At NACTO, we do this by convening, by hosting conferences, workshops. We do this by collaborating, by facilitating fellowships and discussion groups. We do this by curating. That's where we write design guidance like the Urban Bikeway Design Guide, but we also have other design guides and other reports and practitioners' papers. We do this by communicating and elevating city voices in the broader media. If you are interested in getting more involved with NACTO, and especially if you work at a member city or agency, please look into joining us at our conference at the end of May. Registration for that closes at the end of the month in about a week. But it is a great time and a great opportunity to learn more about what's in the Urban Bikeway Design Guide, as well as a lot of other things cities are focusing on across the US and Canada. But what we're focusing on today is what is in this new 3rd edition of the NACTO Urban Bikeway Design Guide. It's been a little over 10 years since the 2nd edition was published, and this is a really comprehensive update. It goes into a lot more detail on topics that were in the previous edition, and it also adds a lot of new topics that had not been previously covered in the last edition. The guidance is centered around bikeways, and as the title says, it's definitely a bikeway design guide, but there's a lot of guidance that applies to streets in general and making streets safer and more accessible for all users. The book comes in at just over 400 pages, which is not quite double the length of the previous edition. There's a lot of guidance that's updates and to previously published documents and a lot of new material. This slide shows some of the material that has been updated from the second edition in green, from our All Ages and Abilities guidance, which was a standalone document published in 2017. That materials really throughout the guide, but for the purposes of this slide, I just highlighted it in one location. And highlighted in this purple gray are the sections updated and enhanced from the 2019 design guidance called Don't Give Up at the Intersection. Highlighted in yellow is all of the new material. There's a lot there, and I will share highlights from each chapter, but the yellow includes network planning guidance, project development, some new facility types like advisory bike lanes and paths, other mid-block features like bus stop design and accessible parking, includes roundabouts, includes maintenance needs and temporary traffic control, and more. Okay, so diving deeper into each chapter. Chapter 1, Envisioning a Bikeable Urban Future. The first chapter sets forth a bold vision for a bikeable city. A city that's vibrant and equitable, economically strong, safe, and sustainable. But beyond setting the vision, this chapter, and really the entire guide, pretty much makes it clear that it's not enough to just say that biking is an important part of the vision. This chapter is aimed at leaders and supporting them with strategies for meaningfully and productively investing in these visions. So updating streets that have not been changed in decades is hard work and requires real leadership. Organized into 3 categories, investing in organizational capacity means building systems that makes the work easier each time. So think about a time you had an administrative or organizational challenge. Have you had that challenge more than once? Was there an effort to address the challenge? Or has it just been accepted as part of the process? Did you tell your leadership about the challenge? Was it addressed? How do you wish your leadership would have handled it? This guide supports strong leadership decisions in addressing these challenges and investing in organizational capacity to make the work easier each time. Investing in trust and accountability means creating clear and transparent priorities, clear decision-making processes, and tracking implementation progress publicly. Do you know where to point, for example, do you know where to point people when they ask questions? Can you confidently tell people about next steps and timelines? Do you feel confident in your own project timelines if you are managing projects with a city? Strong leaders can prioritize this transparent and frequent communication to build trust within departments, across departments, and with communities. And finally, investing in project implementation. This is a given, of course. Projects need to be funded, but reliable and sufficient funding really enables staff to make tough and important decisions about how to design projects and how to confidently move projects into implementation. I'm teasing this icon here to remind you that it will mean trust and accountability alongside organizational capacity and project implementation as these 3 tenets here. Okay, chapter 2 on planning and project development. We're going to be going through just some high-level things. There's a lot in this guide, as I said, but moving right along. To build a bikeable city, the bike network needs to be planned strategically and equitably. Not every bike route in a city will serve the same function, and it's important to consider that function when designing bikeway features. Is a bikeway segment going to be a critical link for the network? Will it be the busiest segment of the network, or will it be an extension into a community that serves fewer people? All those contextual elements will impact design and planning. And to build bikeable cities at scale, cities need to shift from a project-based approach to a programmatic-based approach. And this shift requires reliable funding, which we already talked about. And this table serves as a guide for investing in organizational capacity to make the most of that reliable funding, to shift from a project-based approach where every project might be a fight to a more programmatic-based approach, not to say that that eliminates any controversy, but it creates a system for addressing pushback. And with this scaling up in organizational capacity, a lot of these strategies that address organizational capacity are also strategies that build trust and transparency. And that's where that icon shows up again. A lot of the strategies that will do more than one, address more than one need in an organization. Okay. This third chapter, Bikeways chapter, includes a lot of information, of course. I think of it as the mid-block chapter versus the intersection chapter, which is next. And this is where the second edition, the last edition of our book, really started. So one of the really important updates in this edition was all of the policy, the programmatic, the project development guidance that I've just gone over at a very high level. All of that material, all of the first 60 pages is new to this edition, setting up the designer for understanding the important context behind the decisions of the technical details. But really, this chapter doesn't just jump into facility design details. It starts with foundational principles that we need to design for comfort. We need to design for the least confident rider, and this does not preclude use by the most confident rider. We need to design for growth. All ages and abilities bikeways should appeal to the current riders and the potential riders. They should physically accommodate busyness and wide bikes and speed differentials, and not just physically accommodate that, but comfortably accommodate that. And they should use lasting infrastructure where it matters most, where the most critical safety needs are, or where the most critical gaps in a network are. So we use this term all ages and abilities bikeways. All ages and abilities bikeways are designed as safe and comfortable for people of all ages, all sizes, all physical abilities, all experiences. High quality and connected networks go beyond that, though, by creating a sense of safety and helping people feel as though they belong in a space, that they don't need to ride on a sidewalk, and that they're less likely to have a potentially dangerous interaction with police officers for breaking some sort of standard or literal legal framework. Okay, so each rider comes with their own backgrounds, their own identities, and their own preferences and their own physical bike size. And we need to not only design for that physical space of the bike, but also for the comfortable space of the rider. A close pass where someone whizzes by you, or a narrow pinch point along a bike corridor are likely okay once in a while. But if they happen every ride or multiple times a ride, it could be enough to stop a less confident or even more confident person from riding. And when we think about what is comfortable and what is not comfortable in terms of passing, we need to consider that we all have sort of a minimum and a preferred riding envelope around us when we're using bike corridors. And we have this in all spaces that we interact physically. And that different people have different comfort levels with people and other objects entering their space. And the speed that we are traveling will impact this. And the speed that others are traveling will impact your comfort as well. And the more we have speed differentials, the more frequent these passing occurrences will be. If everyone was riding the same speed, no one would ever pass each other. And the more frequent faster riders are, the more the slower riders will be passed. And the more important it is to have these passing interactions be comfortable. So going back to the same picture, you can imagine, and these are just assumptions and generalizations, but you can imagine this faster rider on the left in more yellow color is potentially more comfortable with a very small envelope around them, and they would take advantage of any opportunity to pass. Theoretically, maybe that's not the case for them. And this rider on the right in this redder color, riding with a child on the back of the bike, is maybe a little bit more sensitive to people entering their space. And if we know that a variety of people of riding with different comfort levels and different speeds are going to be using a quarter, we need to think about the implications of what it feels like to be passed and to be passing. And people's riding envelopes change based on a lot of factors, and you can see that on any group ride as you watch people ride next to each other. They might ride farther apart when no one's around, and they might get quite close together during crowded places. That's not to say that those crowded moments prevent them from riding or totally degrade the experience of the ride, but the more that those kind of conditions exist, the more stressful a ride becomes. And so in this guidance, we have a table thinking about what kind of passing and what kind of comfortable passing can occur based on what types of bikes people are riding on both one-way and two-way bikeways. So for example, if you're trying to allow cargo bikes to pass each other comfortably, and ride and have other riders ride side by side comfortably, you're going to need a rideable width a lot higher than a standard minimum. And I use this term rideable widths here. Rideable width is a little different from clear width and a little different from a marked bike lane width. The rideable width is narrower than the clear width because it does not include the shy distance from curbs and other barriers. We don't really expect people to be riding right next to any sort of curb or barrier. And rideable widths can be narrower than a marked bikeway, depending on the configuration, but they also can be, the marked bikeway could be unimpacted by the shy distance as well. So a few quick examples of what I mean by that. We have this bikeway separated by curbs, and there's a little bit of shy distance here that would not be considered part of the rideable width. Here you have a pedicab parked a little bit in the bike lane, and that is a temporary pinch point there where you can see the shy distance would be impacting where that rider might be comfortable riding. Here is a parking protected bike lane with a sort of a smooth transition along the curb. You can see the rideable width is wider than the marked area for the bike lane. And through intersections, you can see the placement of the barriers here are really outside of the bikeway to delineate the motor vehicle travel lane and do not impede the bike lane at all. And so when it comes to thinking about rideable width and bike lane width and designing these widths, the most critical thing is to always place the barriers to ensure that you have sufficient rideable width. And you can do that in a lot of different ways depending on how your buffer is configured. Okay, so now that we have gone over and we understand how to think about the rides and the rideable bike widths of bikeways from within the bike lane, we also need to think about what type of bikeway or facility type do we want to select based on the stress and conditions outside of the bike lane or the motor vehicle contexts. And protected bike lanes are really the only option along high speed, high volume, multi-lane streets. If you have any number of if you have any street with multiple lanes or any high curbside demand, speeds over 25, or motor vehicle volumes over 6,000 per day, we're recommending that for an all ages and abilities facility, you need to create the space for a protected bike lane. And the chapter has lots of facility guidance and guidance for protected bike lanes and other facility types. But the emphasis in this book is that the designers need to use this more technical guidance alongside the guidance and design control thinking that I just went over, thinking about all ages and abilities rideable widths, considering the future potential volumes and speed differentials occurring in a facility, considering the role that the project plays within the network. And all of this comes together to make informed decisions about expanding and connecting an all ages and abilities bike networks. And this is not a plug and play or a one size fits all design guide about putting in certain dimensions and calling it a day. And importantly, a street's speeds and volumes are not fixed, and other facility types may make the most sense along low volume and low speed streets. And we have lots of guidance in here about traffic calming generally and traffic calming specific to bikeways. But traffic calming can and should be part of bikeway design. This is an advisory bike lane facility type included in our design guidance here, which is appropriate only with low volumes and low speed streets. Also in this chapter, we include a detectable surfaces toolbox, helping people better understand and use these detectable surfaces. And these sort of little icons and schematics are included throughout our design guidance to make sure that we're supporting designers in understanding where these surfaces might be used along, especially along constrained project areas where you might have to rely on modular detectable surfaces instead of building curbs. So designing accessible and navigable curbs along bus stops might mean a shared boarding area. This is a design type that we have. We also have bus boarding islands, but you can see how the detectable surfaces are included in this plan view here. We also have guidance on this chapter on continuing bikeways past on-street accessible parking spaces along parking protected bike lanes, really supporting the need for accessible and navigable curbsides. Okay. Chapter 4, whereas chapter 3, the bikeways chapter, was the mid-block chapter, including the facility types and then other features like I just went over, like the bus stops and the parking. Chapter 4 is the intersections chapter, covering intersections of all sizes, like bike boulevard crossings. We have roundabouts, we have signalized intersections, and the like. But there's 4 critical principles to intersection design and intersection design of all sizes. The first principle is to rethink the intersection and reassess your priorities. What turns need to happen where? What directions of motor vehicles need to be accommodated? How much delay is acceptable? What is the real priority at that intersection? And we also need to provide distinct paths of travel, making it clear who goes where with what priority. We need to slower turns and slower approach speeds are critical for safe interactions at intersections. And we need to improve visibility, making sure everyone is mutually visible and has time to react to unexpected behaviors. A safe system approach uses design tools to minimize severity of crashes so that mistakes are not fatal, but we cannot expect to eliminate every single potential conflict. So at intersections with relatively low turning volumes, geometric design tools like the ones used in a protected intersection design shown here are often sufficient for mitigating conflicts. For example, the protected bike lane approach and the visibility zone, shown with numbers 1 and 4, support mutual visibility among users. And the cross bike markings, number 5 on this diagram, provide a clear path of travel for bikes through the intersection. And the corner island and bikeway setback, numbers 2 and 6, improve visibility and reduce turn speeds. So, but at busy intersections, signal timing strategies can fully or partially separate turning vehicles from conflicting bikeway movements, and this addition includes some contextual guidance on when and where to use that phase separation. This table is definitely in the weeds, but it shows some of the guidance that we have to determine what level of phase separation may be appropriate given different contexts. So the more conflicts you have per cycle, the more separation you'll need to provide for people biking through the intersection. I think this is a really exciting piece of our design guide, and we have a training at our conference in a month called Designing Bikeable Intersections, where we will get into more of the detail behind the thinking of this kind of technical guidance. But finally, we wrap up the guide with a chapter on maintenance and operations. When it comes to keeping bikeways clear, we really have to think about how these practices will be iterative. We can't let perfectionism impede progress, but we can continue to expect better. So when we start small, we evaluate and we update protocols. That's how we build these practices into our work. And collaboration across teams is essential for this. Leveraging expertise of people in all departments will identify locally preferred practices. And as we progress with strategies for keeping bikeways clear, it's important to celebrate success and communicate challenges transparently to continue to build that trust. Of course, all materials require some amount of maintenance, and we need to, as designers, try to anticipate maintenance needs during design. That means considering the speed and frequency of potential traffic incursions, and it also means understanding the implications of existing conditions and that we should never be intensifying inequities. So in other words, don't let a bikeway fall into disrepair in an area that has already been disinvested in. We need to invest in better protection and more frequent maintenance where it's needed, and that might be to address inequities, or that might mean to harden protection along a high volume turn corner. Finally, we as a profession need to do a better job committing to keeping bikeways operational during construction and other closures. This chapter supports with guidance on policies and practices and designs that address a variety of common closures. And although individual closures are temporary, we can remember that construction itself is not temporary, and it's instead a permanent condition with temporary location. So investing in these practices and policies is a long-term strategy for keeping the network clear and connected. Okay, that's the guide in a pretty small nutshell. And I want to close by emphasizing that this edition is more than just a set of dimensional requirements that get put together to create a facility, but instead this guide is a blueprint for thinking really critically about designing streets for people, addressing the needs of a location, and selecting the design tools most appropriate for addressing those challenges. And if you haven't already, you can pick up a copy of our guide online by purchasing it at this link. Using the code webinar gets you 30% off the book. So if you purchase through Island Press, there it is, you can get that discount by attending this webinar. And with that, I will close. Thank you so much for having me.
Great, thanks, Cary. That was awesome. Great presentation. Yeah, it was super cool to see not just some great design, but also thinking about context and tying it all together into high quality connected networks. So that was a really great presentation. Thank you. Again, any questions from the audience, please put them in the Q&A box at the bottom of your Zoom screen. And so with that, we will get over to the AASHTO Bikeway Design Guide. So presenting for the AASHTO Guide, we have Jeremy Chrzan, a licensed professional engineer with 25 years of experience. Jeremy is Toole Design's multimodal design practice lead. He was a key author of the 2024 AASHTO Guide for the Development of Bicycle Facilities, focusing on safe and accessible bike infrastructure. Jeremy has designed numerous bikeways and sidewalks and serves on the National Committee on Uniform Traffic Control Devices, bringing expertise in active transportation and pedestrian accessibility. So, Jeremy, the floor is yours. Thanks for being here.
All right, I assume you can see my screen. So thanks for having me. I'm going to take a similar approach of providing a lot of information to you in a fairly short period of time. So about 100 slides in the next 25 minutes. So I'm going to move quickly. I'm going to throw a lot at you. And my hope is that my goal is to introduce you to the content of the guide and the structure of it, with recognition that we can dig a little deeper into the details during the Q&A. Before I really dig in, I think it's important to look at the history of the AASHTO Bike Guide. So there was a really great paper that was written by Bill Schulteis, Rebecca Sanders, and Jennifer Toole that was presented at TRB a few years ago that really dug into the history of this guide and draws attention to the fact that back in the 60s and 70s, we had parking protected separated bike lanes, and now those roads have conventional bike lanes with mixing zones. Why is that? The 1974 edition of AASHTO actually had a lot of the things that are included in this guide, like parking protected separated bike lanes and protected intersections. It highlighted that you shouldn't drop like bike lanes at intersections and you should mark bike crossings. It talked about the benefits of two-stage turn boxes and protected intersections to mitigate right hooks. But unfortunately, vehicular cyclists got upset with some of the mandatory use laws that were also being enacted and felt like they were losing their right to the road. And they got heavily involved in the AASHTO process. So when the 1981 edition came out, all of that good stuff was removed in favor of things like wide outside lanes. But as we kicked off this project, both NCHRP and AASHTO gave us guidance that this document needed to meet the needs of people who either can't drive or choose not to drive, while also recognizing that we needed to be flexible to the individual communities and locations where these facilities are being installed. In short, our design user is changing from that highly confident bicyclist to people of all ages and abilities, or what we referred to as the interested but concerned bicyclist. So jumping into the guide itself, this is the structure or layout of the guide. There were a lot of changes since 2012. We did a lot of revamping of the structure of the guide, really with the focus on making this more usable for practitioners. There is 625 pages of content, so the length of the guide did increase. That's 9 new chapters. But all of that extra pages is not just text. We also have 3 times the number of figures, so 230 figures in this document, and 2 times the number of tables and charts, again, to put details right at people's fingertips and make the guide easier to use. So let me just jump right in. Chapter 1 provides the introduction to the guide. Please do not overlook this chapter, as it really does establish the framework of all the content that follows. It talks about our approach to design values that are used throughout the guide and this concept of design domain, and that really designers should be picking values in a recommended range while also understanding the flexibility they have to deviate from that. So we make it very clear that selecting values in the minimum range is likely to diminish mobility, safety, and comfort. So it is something that we can use in a constrained condition, but is not our default. Instead, we want to select values in the recommended values range. This is going to best meet the needs of our design users and address that safety and comfort. People ask how this document relates to other design guides. In chapter 1, I think we only mention the MUTCD, the AASHTO Green Book, and PROAG. However, there are lots of guides, including NACTO, that should be used in conjunction with the bike guide. Really, these are all complementary documents working to achieve this goal of meeting the needs of the interested but concerned user. I will say the AASHTO team scrambled to make updates to the AASHTO Bike Guide as the 11th edition of the MUTCD was released a few weeks or months before the AASHTO Guide came out. So they did a good job of making most of the changes, but you will find some things like use of the bikes may use full lane sign instead of bikes allowed full use of lane, or use of the helmeted bicyclist on all the figures. But by and large, the guide addresses the updates to the MUTCD. With regards to the MUTCD, this is the first AASHTO bike guide that gives any guidance on treatments that are considered experimental. So we do flag this in the guide with these gray boxes around treatments that require a request to experiment from Federal Highway. But it's great that those are included in this document. Chapter 2 is probably the most researched heavy document. There's at least 80 citations in this chapter. It really relies on a safety-based focus to the recommendations throughout the guide. Here we talk about the relationship between perceived comfort, or the comfort that people feel when traveling along a facility, versus the actual or substantive safety of those locations. And I think this photo really does a great job of illustrating that this person biking with children is much more comfortable biking on a wide sidewalk than in the bike lane on a 40-mile-an-hour roadway. Really drawing attention to this idea of, as volumes and speeds of motor vehicles go up, there's a greater need for separation from that moving traffic to address the needs of that design user. We also talk about the safety in numbers principle, that a bicyclist's risk actually goes down as the volumes of users increase. And so by providing more safe and comfortable facilities, we're encouraging more biking, which is more likely to lead to safer interactions. As I said, our design user is that interested but concerned user. They make up the greatest percentage of potential bicyclists. And if we design for them, we'll also naturally accommodate the somewhat confident or highly confident bicyclists. We also give a lot of information about the guiding principles of design, driving home the point that separated bike lanes are preferred over striped or shared lanes, that one-way separated bike lanes are generally safer than two-way separated bike lanes, and that two-way separated bike lanes on a one-way road are preferable on the right side over the left side. This is also the chapter where you'll see that buildup of physical, operating, and shy spaces that we use to develop recommendations throughout the chapters ahead. Chapter 13 is bicycle planning. The principles that we identify in this chapter are safety, comfort, connectivity, and this concept of legibility, that our bike network should be intuitive and easy to follow without significant workload from somebody who's traveling along there. This chapter also talks about the different ways that we can analyze our bikeways, drawing heavily on the level of traffic stress, though we do talk about bicycle level of service in a more rural context. Chapter 4 gets into bikeway selection, or choosing your bikeway type. This really mirrors a lot of the content that you'll see in Federal Highway's Bikeway Selection Guide. Again, driving home the point that if we're going to design for that interested but concerned bicyclist, we should use level of traffic stress to assess what facilities are going to be safe and comfortable. And generally, as I said, as the volumes and speeds increase, there's a greater need for separate facilities. In the rural context, we do rely on the bicycle level of service analysis, recognizing that more often than not, in the rural context, that highly confident bicyclist is our design user, but it doesn't preclude you from designing for that interested but concerned user and using level of traffic stress. We also discussed the different strategies that you can use in these constrained environments to deal with trade-offs, and how do we actually find the space for the facilities that are recommended, while also drawing attention to the fact that sometimes, based on the context of our project, it's just mill and overlay, we can't find enough width, that there may be a need to look for an alternate bike route that will meet the needs of that design user. Chapter 5 is one of the most important chapters in the guide. This is where we're going to discuss sight distance and common topics that are applicable to many different bikeway types. We really didn't want to repeat the same thing over and over each chapter, so it's all sort of combined into this chapter 5, elements of design. We talk about this understanding of right-of-way on our roadways, and that there are different situations where different users have the right-of-way at different conflict points. We talk about stopping sight distance. In addition to giving you the formulas, we provide a lot of lookup tables so that you don't always have to do the math. You can just go to the tables themselves. We also draw attention to the fact that there are situations where conflicts are expected between users, like at intersections, where bicyclists are more likely to react quickly, whereas there are other locations with less expected conflicts where we should use a larger perception reaction time. As I said, there are situations where one user has the right of way versus the other user. And as we look at shared use path and protected intersection approaches, this idea of approach clear space is what we developed to identify what space is needed on the approach to an intersection so that both users can see one another and can see which user will reach the conflict first and therefore has the right of way in those locations. And this is all contingent on how we design those corners and how quickly we can slow turning motorists to address these conflicts. We also give a lot of sight distances for separated bike lanes. So example here is case U1, where a motorist is crossing a separated bike lane from the near side of the street. Case U2 would cover the opposite, where they're crossing from the top side of this image and crossing the bikeway on the far side. We actually have this variation of this sight distance as well. It's more discussed in chapter 7, but I just want to highlight it here, that there are certain times where the motorist will inch forward into the crosswalk after they've seen that there aren't pedestrian conflicts, look for bike conflicts. If there are none, inch forward to the point where they can see approaching motorists. We give a lot of sight distances for shared use paths, also trying to draw attention to the fact that with the appropriate sight distances, we do not need to stop control our shared use paths. If both users have enough sight distance, installing unnecessary stop signs is really not necessary. And again, the handy dandy lookup tables so that you don't have to do all the math of the formulas that we provided. Sight distance for horizontal curves on shared use paths, very similar to what you'll see in the previous edition. And then this chapter is also where we discuss intersection design objectives. So reducing exposure, reducing speeds, communicating right of way, and also recognizing that intersections are the places where transitions from one facility type to another are most likely to occur for bicyclists, and how do we handle those locations. We also talk about issues of bicyclists trying to cross challenging collector and arterial roads, and this recognition that motorists are less likely to yield as the number of lanes or the speed or both of those roads increase, and sort of draws attention to the fact that we may need more countermeasures to allow bicyclists, let's say on a bike boulevard, to cross a challenging arterial street. So sort of building off what you might see in FHWA's STEPS guide for pedestrians, we provide a similar table that identifies a certain tier of countermeasures that may be appropriate based on the conditions of the roadway that those bicyclists are trying to cross. And then, as I said, we also discuss intersection design and safety. within this chapter. So drawing attention to the fact of at protected intersections, we can use things like mountable truck aprons to slow turning vehicles. We can use things like raised crossings to, again, slow turning vehicles, also elevate pedestrians and bicyclists and help to make them a little more visible. We also talk about bike ramps in this section, as well as other tactile surfaces for pedestrians. This is just an example from Austin of a built example of the concepts illustrated in AASHTO. And then in this chapter, we talk about the use of directional indicators along sidewalk level separated bike lanes. We also drive home the point that sidewalk level has these challenges of pedestrian accessibility that should not be overlooked in the design process. And then closing out chapter 5 is where we highlight the various signs and markings that can be used to delineate or help to communicate to bicyclists. So things like the bicycle crossing markings, two-stage turn boxes, etc. Digging into the actual facility types, chapter 6 covers shared use paths. There's not a whole lot that's different in this from the previous edition, but we do try to drive home the importance of that the volume of users that are expected should really be the deciding factor in how wide our shared use paths would be. And again, we do not provide a default width for shared use paths, but we make it clear that if you do a 10-foot wide shared use path, you're really only providing 2 operational lanes for users, that a simple change to at least 11 feet will give us 3 operating lanes and allow shared use paths to operate a little more efficiently at lower volumes. A lot of this is built off of Federal Highway's shared use path level of service calculator tool. So again, we have a handy dandy lookup table to look at based on your volume of users and your widths, what would be that shared use path level of service. And at some point, based on the volume and mix of your users, it may be appropriate to separate pedestrians and bicyclists into their own separate spaces. We talk about the shy distances and adjacent facilities that you need along a shared use path, all those horizontal and vertical alignments. Though again, we give you the lookup tables so that you don't have to do the math. And then we also give the various intersection approach treatments that you might use for a shared use path that's crossing mid-block. And again, driving home the point that the unnecessary installation of stop signs should be avoided unless they're absolutely needed. Chapter 7 covers separated bike lanes as well as side paths, since there's a lot of similarities between a shared use path running parallel to a road is very similar to some of the characteristics of a separated bike lane. So we talk about the different zones and spaces that are needed, not just the separated bike lane space itself, but the street and the sidewalk buffer. Ooh, skipped a slide. We talk about the different elevations that a bikeway can be installed at street level, at sidewalk level, or at an intermediate level between street and sidewalk level. And again, talk about the trade-offs associated with pedestrian accessibility with those design treatments. Similar to what Cary was talking about, we really build in this idea of shy space into the widths provided in the guide. So based on the conditions that you have, are you between 2 vertical curbs, in which case you're going to need more curb to curb width versus a facility that might be at sidewalk level or adjacent to sloping curbs where those shy distances are essentially non-existent. We also talk about how you drain, how you deal with the stormwater associated with separated bike lane implementation, and that there are a lot of different strategies that can be employed based on the type of project that you're implementing. Section 7.9 discusses intersection design and this concept of protected intersections. As I said, separated bike lanes and shared use paths have similar characteristics, and you can see the characteristics of a protected intersection are very similar for those 2 facility types. And then we dig into the details of some of the elements of those protected intersections. So the corner island, what is the purpose of that? It's the thing that's going to give queuing space for bicyclists. It's the thing that's going to slow turning motorists and get them to yield and better respond to crossing bicyclists. We talk about that not all locations will be able to have a protected intersection. And so if we are doing mixing zones or dedicated right turn lanes, that generally we want to keep those lengths of those right turn lanes as short as possible so that motorists entering those spaces are entering as slow as possible, as close to the intersection, and that we can use flex posts and buffers between the right turn lane and the through lane to further reinforce that we need motorists to enter those spaces more slowly. We also discuss how to accommodate accessibility with separated bike lanes. This is an area where PROAG was released and the graphic doesn't necessarily reflect the guidance in PROAG. So really this is more illustrative of the type of treatment that you would have to deploy to both meet PROAG as well as accommodate the separated bike lane. We talk about how to accommodate transit and separated bike lanes with the design of floating bus stops. Lots of different variations of this are discussed in the guide, understanding that some will be designed as a retrofit, some will be designed as a reconstruction. How do you deal with those different types of interactions? And then separated bike lanes have some unique challenges in dealing with transitions from one facility type to another, particularly two-way separated bike lanes. So while we can't possibly show you all the different transitions, you'll find a lot of different examples of transitions in this chapter. We also discuss this idea of a raised bike lane, which is sort of a hybrid of a conventional bike lane and a separated bike lane, really only appropriate in our most constrained conditions, but it does have its place in the design guide, and we provide you the information needed to design that. Chapter 8, bike boulevards, planning and design of that facility. So showing you the target volumes and speeds to allow this to be safe and comfortable for that interested but concerned bicyclist. As well as some of the traffic calming strategies. That's not just vertical deflection, but also horizontal deflection, things like medians and chicanes, and that they can have a benefit of helping to control motor vehicle speeds if they're slightly above what's desirable. Similarly, if the volumes are higher than desirable, we can consider traffic diversion strategies. So we give a lot of different options for traffic diversion, which is intended to reduce the motor vehicle volume slightly just to get us below those more comfortable thresholds. We also know that bike boulevards aren't always straight and that they might have offset intersections and other unique geometry that we're trying to accommodate. So we give you some examples of how to deal with some of those transitions at some of the challenging locations. Chapter 9 covers shared lanes as well as conventional bike lanes for various contexts. So we do talk about the installation of shared lane markings. We give guidance on the widths, again, recommended as well as practical minimum widths for conventional bike lanes, recognizing that those widths should respond to the types of conditions that we're biking along, and that biking along on-street parking versus biking along just an edge of pavement have slightly different width requirements that we should be considering. We know the challenges of bike lanes installed in the door zone, so we give some guidance on door zone markings that can be considered in our most constrained conditions, while also highlighting that buffers can provide a much better benefit to deal with this door zone issue. And then again, we talk about some experimental treatments. So advisory bike lanes are discussed in chapter 9. We also talk about that at some complex intersections or locations with high volumes of right turning motorists, there may be situations where we want to give an option for a bicyclist to exit from the bike lane to an adjacent shared use path so that they don't have to deal with those motor vehicle conflicts. Probably most appropriate in a suburban context, but again, giving you the tools to consider that as a design option. Chapter 10 is traffic signals and hybrid beacons. So we give the different variations of treatments that can be used for controlling bicyclists. We provide some threshold volumes of right and left turning motorists across one-way or two-way separated bike lanes, and where the phase separation should be considered for those movements. We give some various options for the placement of bicycle push buttons, though we also highlight that other detection like loops and video detection can be preferable for bicyclist detection. You'll find all the guidance on red time as well as green clearance time for bicyclists in this. Some complex formulas, but it's important to be considering the speeds of bicyclists when timing traffic signals. Chapter 11 gets into interchanges and alternative intersections. So talks about how we should be considering the redesign of interchange on and off ramps to better mimic the intersection design principles that we discussed in chapter 5. And so again, we can deploy things like mountable aprons and alter the geometry to sort of make these intersections a little more closer to right angle as opposed to the high-speed slip lanes that we often see in these types of locations. Also recognizing that these weaving movements create some really challenging conflicts, and these might be locations where you want to give the option for the bicyclist to exit to an adjacent shared use path. And then also looking at some of these alternative intersections where bicyclists and pedestrians are moved to different spaces that are a little less conventional. How do we deal with those accommodations in those locations? Some thinking on how we approach slip lane design for the locations where a slip lane is absolutely necessary. So use of raised crossings, altering the geometry, et cetera, are discussed in this section, as well as the design of the approach of roundabouts and that option of providing the bicycle ramp so that they can exit, as well as showing how separated bike lanes may be accommodated at a roundabout. Chapter 12 is going to cover rural area bikeway design, so giving you the widths that may be appropriate for shoulders based on the volumes and the speeds that are experienced on that road. We talked before about these are locations where we are generally designing for the highly confident cyclist, but also recognizing that if there are clear community destinations or perhaps shared use paths that people are trying to connect to, that we do need to design for that interested but concerned user. And then we also discuss advisory shoulders in the rural road section, and advisory shoulders similar to advisory bike lanes, but are expected to be used by both bicyclists and pedestrians. And then we talk about the placement of rumble strips so that bicyclists that are operating in the shoulder, how can they enter the travel lane if there's debris or obstructions in their path? Chapter 13 gets into structures. The main thing I want to stress from this chapter is we really tried to drive home this idea that you need to account for the shy distances from railings and barriers on bridges and on structures. So for example, a 12-foot wide shared use path that is approaching a bridge should really have 14 to 16 feet on the bridge of clear space from railing to railing so that the operating width of that facility remains consistent. Chapter 14 gets into wayfinding and the importance of that legibility component. So we have some of the guidance for the sort of MUTCD compliant or standard bike route signs, as well as some of the more branded examples that we often see. Chapter 15 covers maintenance and operations. As Cary said, something that really should not be overlooked. And so we talk about the different strategies for maintaining these facilities and things that should be thought of during the design process to improve the longevity of those facilities. And lastly, Chapter 16 covers bike parking as well as bike share siting and end of trip facilities. So showing how some of these facilities may be implemented in the street or in the sidewalk gives all the spacing and bike rack types that should be considered and or should be avoided. And then I think you're the first or second group that has seen this code, but AASHTO recognizes that their guide is quite costly. So for training attendees, they've offered a 10% discount using the code that's here on the screen. And I can put that in the chat as well. And with that, that's all I had. Looking forward to your questions.
All right. Since we are just a little bit over the hour, I'm going to just focus on a few questions that are more or less yes, no answers. So we have the question here, can these design guides be used for scooters?
Absolutely.
All right, cool. Will AASHTO publish updates on their websites about PROAG MUTCD guidance that came out after and is inconsistent with the bike guide?
So I know they've released some errata, and those were specific to typos and other things that happened as part of the publication process. As I said, they did make substantive updates to some of the graphics to align with the MUTCD. Things that we had flagged as interim approval were listed as, approved treatments. I'm not sure of their intentions to make more substantive updates. So I'm just trying to use them all in concert, and then during trainings, trying to draw attention to the differences that people need to be aware of.
All right, and then last question for Cary. Will NACTO be publishing any additional diagrams when the book is put onto the website?
Not specifically with that. Yeah, thanks for asking. I want to emphasize that all of our guides are on our website as our practice. But we released this at an interesting time with our website redesign. So right now we only have our urban street design guide on our website. All of the other guides are in queue to be put onto the website, and this third edition of the Urban Bikeway Design Guide is up and it's underway. It's up in the queue. It's not online, and it will be online in the next couple months. Just the exact material that's in the book, nothing additional, but we will be working on creating a training program over probably in the next year. Like not this year, but that kind of effort might create other kind of graphics, and we'll think about whether those make sense to be included online. But that's sort of a future effort that I'm just teasing right here.
Awesome. Did anybody have any final comments? If not, I will let Nick close it out.
Yeah, just wanted to thank our two presenters, Cary and Jeremy, again. Awesome presentations, great work being done out there. And thank you everybody who attended, and make sure to check out Center for Pedestrian and Bicyclist Safety, check out our website, and sign up for other webinars, newsletters, and all of that. So thank you. Hope everybody has a good day.